Notes on rational versus irrational numbers. We're going to start off with what a rational number is. And remember, if I go too fast in the notes, you're going to just pause and write down what you need. You're not going to write down necessarily everything word for word. You're going to take notes that apply to you. So a rational number is a number that can be turned into a fraction. A number that can be turned into a fraction. Okay? And the formal definition of it is kind of more of a ratio of two integers where it's a over b, and b cannot be 0. So that's kind of the disclaimer when I say a number that can be turned into a fraction. The denominator cannot be 0. Also, as a decimal, a rational number terminates, which means it ends, or it repeats. It's the same thing over and over and over and over. It's the same kind of pattern. So some examples of that would be 3. That's a rational number. 0.6 repeating, so that's 0.666 and so on. 2/3, because that's 0.6 repeating actually. -2. The square root of 25, which means what number times itself is 25, which is 5. 10%. 5 to the second power, which is 25, or 0.23. That's a terminating decimal as well. I'll give you another one. A rational number that is a repeating decimal could be 0.124, It's a repeating decimal. That would be another example. Meanwhile, an irrational number is a number that can't be turned into a fraction. As a decimal, it goes on forever, and it never repeats. So my guy up here goes on forever, but it repeats, so that's rational. Irrational goes on forever and never repeats. So for example, I have 0.54378, That means it's going to go on forever, and there's not an identifiable repeating pattern, so you're good with that. It's just going to be irrational. Pi is an irrational number, and if you're not sure about that, take a look at the poster in the very back of my room, which is by the doorway that goes to Miss Gallagher's. That's a poster of pi, and you can see that it goes on forever and ever and ever, and at the end, there's a ... Square root of 2, that's another irrational number. It's going to be a decimal that goes on forever. Okay, now some really quick notes here. A rational number times a rational number is always a rational number. For example, 3 times 5 is 15. That's just one little example. A rational number times an irrational number is always an irrational number. For example, 4 times the root of 2 is 4 root 2. And if you write that on your calculator, 4 root 2, it's going to be a decimal that goes on forever. An irrational number times an irrational number is dependent. So I've got some examples here. Pi times pi is technically pi squared, which is going to go on forever. But I have the root of 2 times the root of 2, which is actually the root of 4, which is 2. So that's a rational number. And then pi times the root of 2 is pi root 2. That is also an irrational number. So it depends if it's an irrational number times an irrational number. And then I wanted just to remind you, we've talked about this already this year, but any number divided by 0 is undefined. Any number divided by 0 is undefined. These are short and sweet notes, so guess what? That's it. You're going to be able to do that worksheet now and decide whether numbers are rational or irrational.